Sweet. Hey guys, my name is Tylen Ward, and I am doing my presentation on the evolution of chemosensory preferences in the female Aedes aegypti. So just as an introduction, mosquitoes, as we know, are one of the world's most dangerous animals. They are continuously infecting millions of people every year, and they're getting smarter and smarter, and they're able to better propagate these pathogens. So I wanted to specifically target the female Aedes aegypti because she carries 4 known pathogens, which include the yellow fever, the dengue, Zika virus, and the, forgive my pronunciation, but the chikungunya. And so I want to talk about how we're tracking these behavioral and biological adaptations, and also how we're trying to stop them. So just to give you a little history on this mosquito, it originated from Africa. It was found mainly in parts of East Africa and the sub-Saharan areas, and then it migrated to various parts of the world through the human trade movements, and so now it's found in almost every subtropical area on the planet. So as we see the physical migration of the mosquito, we can also see evidences of genetic drift, and we can see that from increased FST values. So we saw a range from 0.873 to 0.359 in a study from J. Brown in 2013. So that is extremely high. Our FST values, the 0.08 isn't too high, but seeing a 0.359 range is definitely displaying notable amounts of speciation. So we could first see the behavioral adaptations of this mosquito as we see its preference in targeting humans. Its ancestral form used to only preferred to target forest animals, and just like didn't have a preference for the vertebrae that they targeted. But now you could see that there is a increased preference in humans. It's been thought that they've been linked to carbon dioxide emission, and we can see that here on the next slide. It's been thought that it's been linked to carbon dioxide emission, but we can see that there's a strong preference in any type of stimuli from the female mosquito, regardless of what it is. And so to better understand the biological changes that are being made, we want to look at the different types of receptor stimulation that's being made in the olfactory bulb. And so to do that, we're going to look specifically at the type of odorant receptors that are being produced and expressed. So we see that there are high levels of ROR4 and OR103 odorant receptors that are expressed in human preferring populations. And so although there is a large variety of these odorant receptors, we could see a consistent presence of the OR4, and so that has been thought to be linked to this human targeting preference. And that was from McBride in 2012. And so what are we doing to intervene on this? So there's been one successful study done where in the past that we have diminished reports of dengue and yellow fever, and that was done in New Zealand in the late 1900s, where different community members all got involved and eliminated all breeding grounds. And so that is the biggest form of intervention that's being used today, is community-based intervention, because it's hard to completely control the environment. It's really hard to eliminate things without the consistent help of every member of your community, it's really hard to maintain this type of intervention. So instead, governments are implementing different educational programs that help inform people about how they can prevent mosquito breeding grounds from forming, how they can protect themselves. A lot of it has to do with like recycling and cleaning up litter and things like that. So we can see that from like the World Health Organization, Doctors Without Borders is involved, the Peace Corps, like these really big government organizations are really just trying to install that innate desire for people to be able to be a part of the community and protect one another. Another type of combating technique is sterile insect technology. And so this is a really cool technique where they physically radiate the male and female mosquitoes so that they can separate them. And then when they do that, they do that to only target males. And when they get only a male population, they sterilize them so that they can't propagate any viable sperm. And so when you do that, you're just eliminating the offspring of these mosquitoes. And so that's been very effective, but it's pretty hard to maintain and do, and it's much slower to give results. But yeah, those are the two main mechanisms I found. And in conclusion, we could see a lot of behavioral and biological adaptations. I mainly wanted to target the chemosensory one because I feel like that's really easy to hone in on. We hear a lot about other things such as pesticide resistance and things like that, and there's so much involved in this when this is specifically dealing with odor receptor stimulation. And the biological and behavioral migrations of the mosquito, and then we've seen positive implications of community-based involvement to be able to inhibit this propagation, this pathogen propagation in the past, and we're still doing more research to be able to move forward and combat this lethal mosquito. So I hope you enjoyed.